Today we're going to talk about the Hubway visualization, which is our data visualization final project. This is Group 10, and my name is Daryl Fletcher. The rest of the group include Nick Amote, Jing Zhang, and Win Bozwo. The data that we chose is from Hubway. And Hubway is a bike sharing system that provides more than 1,500 bikes at 155 stations. The way the program works is you join the Hubway system either as an annual member or as a short-term member, and then you're able to take a bike, ride it, and return it to any station. The data from Hubway's launch in 2011 through the end of 2013 regular season is what we use, and their season ends in November. The data that we collected included the duration, which was the amount of seconds that the ride took, the start date of the ride, the end date of the ride, the start station, so where they picked up the bike, and their end station, where they dropped off their bike. The bike number, which indicated which bike they used, the member type, whether it was a casual member or an annual member, the zip code for any annual member, their home zip code, their birth date, and the gender of the member. Using this data, we ran calculations to calculate the distance traveled and the speed of each ride. So we're going to walk through a demo of our visualization. We took a risk management perspective for our dashboard. So this dashboard is used to estimate the risk of injuries from customers getting in the accident for purposes of creating programs to mitigate that risk. For instance, telling people that they should slow down in certain areas and or to get the correct level of insurance for specific regions or customers. Dashboard. The top of the dashboard gives a visualization of the top fastest zip codes in terms of speed. So right now, the slider is set at the top 20 fastest zip codes, and those are displayed. The average speed of a particular zip code is indicated by the intensity of the red dot, and the size of the actual dot indicates the duration, the sum duration for that zip code. So there are certain zip codes, for instance, here, the zip code 78215 has a very strong intensity. So their average mile per hour of a trip is over 10 miles per hour. However, the duration is only 4 minutes, and that's a sum across all trips. However, we see some of these dots that have low intensity relative to the other top 20 zip codes. For instance, this one has an average mile per hour of 8.158 miles per hour. However, there's a lot of people in this region, in this zip code, that use Hubway, and so the sum of duration in minutes is over 5,500. Using the slider, you can actually go from, say, you wanted the top 20, but you want to focus on maybe, we'll just say top 6. So maybe you want to use the top 6. So we'll move the slider down to the top 6, and you'll see these 6 regions, these 6 zip codes are highlighted, and you can see which of the zip codes have the most people in them that are using Hubway, and see what their miles per hour are. Using this data, you can say that bikes in this region should have special marketing at the station to tell people to slow down when they're traveling, to reduce the risk of injury and therefore the risk of liability on Hubway's side. The visualization at the bottom gives an average speed over the course of over different bands of ages. So as you can see, we have 10 to 19, 20 to 29, all the way up to 80. And you can see that for the most part, males have higher speeds than females in every category. And you can change the quarter or the year, or you can do a select all for the total data, and it changes the data. It changes the visualization to reflect this. Again, you can use this data to see how fast various demographics are moving on the bikes, and thus attempt to mitigate this either by specific marketing, say to 20 to 29-year-old males that are going almost 7 miles per hour. You send them a special message that says, "Thank you for being a Hubway customer. Please make sure to travel safely," or something to that nature. Or you can possibly give discounts to people whose average duration is, or excuse me, their average speed falls below a certain threshold, therefore decreasing the chance of accident from riding the bike too fast. So the distance calculation is based on the distance between the coordinates of the various stations, so their start station and their end station, and using a formula of sines and cosines, we were able to figure out the distance between the two stations. And then based on that, we were able to calculate the speed. Again, the speed was just their distance in miles divided by their duration. So some of the limitations of our visualization, the calculations, the distance calculations, firstly, we use Euclidean distance between stations. Therefore, this was just a straight distance between station A and station B, or the start station and the end station. And we know that rarely, if ever, a straight line between two stations was ever done, just because there are city blocks, there are buildings in the way, and the fact that most people just don't ride their bike from one station to another. And it also doesn't account for people who return their bike to the same station. So maybe they rode, 4 blocks one way and 4 blocks back, or, in a circular pattern. The distance for these people would wind up being 0, and that's just not correct. And that takes us into the speed calculations. Again, since we use our distance calculation, people who aren't going in a straight line, obviously will have a different speed, and therefore, since the distance is going to be greater than what we calculate, obviously the speed will be greater over that specified time period. And also, the calculations are going to be biased. The stations that, or the zip codes that have a lot of people who return to the same station are going to have lesser speed, because they're going to have a bunch of 0 mile per hour that's going to outweigh some of their faster speeds. Some of the challenges that we had with this project is that we use a fairly large data set. And using a large data set, it took a long time to, one, even just share the data amongst the group members, just because trying to send it via email took, it took a while to upload, took a while to download, things of that nature. And then even once we got it into Tableau, it took Tableau some time to query the data every time we made a change, which was a little tedious and time consuming. And then the other challenge was just the group experience, in making visualizations. Most of us have never done visualizations before this class, or at least visualizations that really adhere to the guidelines of creating a great visualization. And when we first started out, we had some very high hopes. We were trying to create a Sankey diagram that was interactive and dynamically generated, and that just became a painful experience, as we just couldn't figure out how to make that work in Tableau. It's a very difficult process to create a Sankey diagram that's very static, let alone interactive and dynamically created. So we found out the hard way. Some of the key learnings is that creating a great visualization is very hard. It's not as simple as previous to this class as just creating a pie chart or something to that nature. The other key learning is, if in real estate, if the 3 key factors are location, 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 and data visualization is definitely data, data, data. The data must be clean, it must be correct and complete. Even going through our data, we were unsure of how correct and complete the data is, just because Hubway is primarily in the northeastern part, New England states. However, we were getting results for places in Texas and California, and we were unsure if this was correct or not. So you really have to know that you're working with some good data. And then finally, that you really must understand the business and its needs to create a good visualization. You have to know what they're hoping to, the information that they're hoping to get out of the visualization in order to provide them with very good data. And with that, that completes our final project of the Hubway data. If you have any questions, please feel free to reach out to us. Thank you.